moderate this second session. I know we had a whirlwind type activity in the first session, a number of interesting presentations, and this second session will be no different. Again, I want to thank my colleagues for joining us in the room, and of course, for the persons who are online. This is indeed an interesting session. This is the third of its kind, third year in a row, where we've seen the level of collaboration among the agencies. And this is spearheaded primarily by the FAO, CARDI, and ICA. And we brought on board other players, the World Bank, co-lead, CIMH, the CDB, and all are represented here in the room. I'm seeing some of the faces. So it's really exciting to hear from you all, whether in person or participating online. I want to get straight into the mix of things. We know that digital solutions can really support the transformation of agriculture in the region. We need more adoption, we need more rather promotion and adoption of the different solutions. So there's hope that through these sessions, we can get that sort of uptake of the knowledge that is being shared, the technology, etc. And I want to encourage those persons in the room and those who are online, get the word out to our farmers, to our entrepreneurs, so that there can be that uptake and awareness building on the digital solutions. I've already been talking too long. Let me move on quickly to the agenda. We have a packed agenda this afternoon, and I want to make a slight adjustment on the agenda and have our first presentation done by Ms. Bronte Tucker, the CARDI representative here in St. Kitts and Nevis, and Mr. Quincy Burt of Nevis. And this presentation is titled My Geofarm Application in St. Kitts and Nevis. When I see my colleague, Ms. Tucker, is right in front of me, and let me just introduce her. Bronte is a premier agronomist with CARDI. She's also the country representative for the island. She has a bachelor's degree in agronomy from the University of Guadalajara in Mexico, so she's a Spanish speaker as well. And she has a master's from Pingting University in Taiwan, so ni hao ma. So we have a very distinguished presenter here this afternoon, and she will open up our batting and allow Mr. Quincy Bart to join us as well. So with that, let me welcome Ms. Tucker and ask you all to put your hands together for her.
Use this one.
And we have 10 minutes, and I'll be timing you.
All right. Good afternoon to everyone. For those, well, good evening. For those joining us online, good evening also. And for those that have been here all day, thank you for being here with us. Right. So as was mentioned before, my name is Bronte Tucker. I am the country representative for CARDI here in St. Kitts and Nevis. And this evening, I'll be presenting to you the My GeoFarm app application here in St. Kitts and Nevis. So what is My GeoFarm? My GeoFarm was developed by Center of Investigation of Tropical Agriculture, which is otherwise known as CIAT, out of Colombia. It facilitates two-way interaction. It could be between farmer to farmer, or the farmer with the extension officer. The app can also collect data, and it can mark geographic location. So the app, when you download the app, you automatically enter into the community, right? So if you download the app in St. Kitts, you would be in the St. Kitts community. This app was also launched in St. Vincent, so if you download the app in St. Vincent, then you would automatically be entered into the St. Vincent and the Grenadines community, right? As moderator, so I'm moderator for the St. Kitts community. As moderator, I can disseminate information to anyone that's on the app. So for example, if CARDI did a research paper and we wish to share that with farmers that are on the app, then I can disseminate that information to everyone that's on the app. So this is what you would see as as a farmer. If you download the app, these are all the farmers that are in the, well, some of the farmers that are in the St. Kitts community, right? So the app um, shows you the location of each farmer that's on the app. So when you download the app, you mark your geographic location of your farm. So it's going to automatically enter your geographic location on the app. And then you click, you create your farm. So you give your farm a name. This is the farm I created. So Natural Creations. The only way that you can see another farmer information is if that farmer chooses to share their information with you. So when you open the farm that you would have created, you're going to see these features that are on the app, right? So there are different features. Fields, you can map the different fields that you have on your farm. So let's say you have watermelon field or even a pineapple field, so then you can map and mark your geographic location of your different fields. And it doesn't even have to be field. You could notice like a insect, a rare insect or a disease, and you could mark your geographic location of that um, insect or disease, and you could share that with your quarantine officer or your extension officer. You could also track your production costs. The app can tell you climate. Sorry. You could make logs into the app. You could log your tasks. So for example, if you want to remember to spray next week or harvest next week, you could put that into your task. And then you have your teams. Teams, you could chat with farmer to farmer chat. So only you and that other farmer that's in your team can see your chat, right? So as I was saying before, you could map your different fields. So this is a map of a watermelon field, and it would give you the geographic location and also the size of the field when you map the field. And as I said before, it doesn't have to be a field. You could map the like an insect or disease that you would have noticed on your farm. So for climate, these are the different errors that the app would, you could see the air temperature, the precipitation, radiation, humidity, evapotranspiration, and soil temperature. And this could give you up to about 3 or 15 days in advance. So that way you could, make a plan as to how you want to sow your seeds or even plant your crops. And for the logging of your log entry, you could make a log entry into the app, as I mentioned before. So you give your log a title. You can take pictures. So as I said before, if you notice a disease or an insect, then you take a picture of it. You enter your details of what you have noticed, if it's an insect or if it's a disease, and you could mark the geographic location and share that with your technical officer. So back in April is when we would have launched the pilot for this app. We had representatives from SEAT came over and introduced the app to technical staff from the Department of Agriculture for both St. Kitts and Nevis, and also farmers from both St. Kitts and Nevis, right? And now I'm gonna ask one of the technical staff from Nevis to um, share with us how this app would have helped him in his surveillance project. Quincy? Or Quincy Bart, quarantine officer from Nevis.
Yes, good day, everyone. I'd like to explain to you the capabilities of my geofarm. My geofarm is a mapping system and a plant quarantine system map used to map for here here in Sinkitan Nevis. We map to plant surveillance on the West Indian fruit fly. So this fruit fly eats soft-bodied fruits, and it does damage by the larva eating the fruit, and it causes the fruit to be unmarketable and decrease yields. So in the old system, it normally we have a logger system, and we use our cell phone to log the mapping system. But with the MyGeo app, it is a all-in-one system that does everything for us. So I'll take you to the application of the MyGeo Farm. So the Geo Farm app. So the MyGeo Farm app, we have a home page. The home page shows you um, the, the type of traps that are established. The picture there shows you the location, and you can you can let you could enter data in whether it's on the farm, such as identifying the, the map, the type of a trap used, the identifier, the description, and your region and the owner. So once that is thing, you can open the app, and you can it leads you to a module called fields, and the fields gives you the geographic locations. Here is the the plots that are already plotted, and we can use the add fields to add a different plots. So we can do it manually, whether if it's can open up the toggles and apply it, or you can use the automatic system where you use your device and you just go around the perimeters of the plot, and it will draw the map for you. So the MyGeo app gives you the size of the plot. You can add pictures to the plot, and also it gives you the geographical location, latitude and longitudinal. In terms of trap location, you could go to the main menu and go to route. It will enable you to go to Google Maps, and the Google Maps will tell you your current location, which is here, and the and the um and the actual location of the, the trap. So here's the location, the login systems. You can log. You have trap ID. If you add a trap, whether you service or you find a fruit fly, it also gives you a timestamp as well. And with all this information, you can do analyze data, update the data on the database, such as the CPHD database, and you can perform Google Maps to say whether what types of traps are on the island. So that's about it for my Geo app.
Thank you very much, Mr. Bart. I know I had to rush you. Very insightful. But you know what's interesting about these sessions? We shouldn't just limit it to the room. I want to invite you all to contact Ms. Tucker and Mr. Bart to get more insights from them so we can follow up on it. As we noticed, the tool is being used in other countries as well and pretty informative. For me, the quick takeaway was that agromet data that can be used to guide decision making as a producer. And I know we have other colleagues like CIMH here who would probably speak to some of those issues as well. So again, thanks, Mr. Bart. I want to ask us to hold questions till halfway during the session. I want to quickly move on to one of our online presenters, Dr. Lopez, who's joining us from co-lead. And I know he's probably 5 hours ahead, so I want to let him present and get to bed. And I want to welcome Dr. Thomas Lopez, and he's going to speak on co-lead support for the integration of digital technologies in ACP, African, Caribbean, Pacific countries. And he's going to showcase a pilot project in Uganda. Dr. Lopez, are you on?
Yes, Simon, thank you.
Great. Before I pass on to you, let
sharing-
me acknowledge your colleague in the room, Benedict Warner from co-lead, and just wave your hand, Benedict, so persons can engage you after if necessary. Dr. Lopez, you have 10 minutes, and I know you'll stick to the time. Thank you.
Yes, just share the presentation. Do you see my screen?
Yes, I can see it. Thank you.
Okay, so thank you very much again for this opportunity to present today. So today I will split the presentation in 2 parts. The first one, I will explain how co-lead supports the integration of digital technologies in ACP countries. And the second one, I will showcase a pilot project that we did in Uganda. So a brief overview of co-lead. So the co-lead is a committee linking entrepreneurship, agriculture, and development. We are a non-for-profit private sector organization. And our mission is to facilitate and implement all actions that allow, directly or indirectly, to increase the contribution of the agricultural and horticultural sector, in particular, to the achievement of the SDGs. So co-lead works in more than 50 ACP countries, and as we are an association, we are composed by members, and most of them are ACP producers, but we work also with all the supply chain, including importers, exporters, research institutes, etc. So today I'm talking on behalf of the Research and Innovation Brokerage Department. So our objective is really to make the link between the solutions and between the different actors and identify solutions and test them in the field to see if they can work or not for ACP producers. And so the idea is really to, we are not really owners of technologies, but rather we try to identify the most efficient and affordable solutions and test them for our members, including producers, and mainly producers. So in terms of digital technologies, more specifically, we want to increase the awareness of technological advancement and emerging opportunities in the agri-food sector. We want to link farmers and processors with research and ICT startups to implement or scale solutions. We also create case studies and implement pilot projects. The one I will present to you, today is an example. So, and the objective is to increase knowledge regarding the opportunities offered by these technologies. So we also provide capacity building on ICT tools and also on IT and web-based solutions to create simple local markets, for example, online and offline for co-lead members. So quite a lot of objectives here. So we focus on different thematics, let's say mostly on production, on the production side. So including, for example, soil analysis, irrigation, IPM, productivity, etc. So basically all thematics related to production, but also We also target different thematics after production, so processing, transport, traceability, etc. So it's quite large. And we also consider different types of technologies. We can go from something very simple as a mobile phone application until artificial intelligence. Of course, this will depend really on the context of the pilot or the technology that we want to test. Okay. Just to mention also that we have a publication that we published quite recently, and here the objective is really to inform the horticultural sector about the different technologies that exist for the ACP countries. And in this publication, we will really review all the technologies, the use cases, the key players, and also challenges and opportunities for each of the technologies. So it's really interesting, and I really encourage you to have a look at it. It's open access. Okay, so after this quick introduction, let's say, about Colid, so here I will deep dive a bit more in the pilot study that we did in Uganda, and specifically in the avocado sector. So the avocado sector is really expanding rapidly, and yet there are some limitations, and mostly due to that we have little data on producers, basically. And what we need is a better identification, but also characterization and structuring of producers and their farming environment, both to support market and value chains, so including marketing, market access to finance, traceability, but also for producers to be able to provide farm-specific recommendations, also technical support, and also timely communication on challenges and opportunity they might find in their farms. So here, the key challenge that we identified is really the limited access. So in addition to that, one of the key challenges is really, the limited access to soil information and soil management recommendations. So what we see is mostly farmers really don't do soil analysis or have little access to recommendations to manage fertilization. So here the objective of the pilot really was to integrate a tool that allowed farmer profiling, so getting information about the farm and also the fields, and integrate this into a business management tool with on-field spectral soil analysis. So what we did basically is we deployed eProd, that is a supply chain management system, to capture farmer and field data. So we went really in Uganda in different farms that you can see in the screen in the different agroecological zones. And at the same time that we would capture farmer and field data, we would capture also soil data with soil scanners. And we did that with another application that is AgroCares. And so we visited not around, but 112 avocado farmers. And so we did both surveys to capture the farmer and field data, and we also did composite soil samples collected with handheld soil analysis. And basically how this works, so we have the eProd to capture the farm and field information, and it will be coupled with the AgroCares that is targeting soil analysis. And so what the person that goes to visit the farmer will collect both information, so the farm information, but also the soil. So we'll perform the soil analysis into the farm. This soil analysis will directly feed AgroCares, who will treat the result and send the report to eProd. And eProd at that time will communicate to field extension officers or even to the farmer the reports and the recommendations. So here I will give you just some examples of what we can obtain from the farm and field data. So for example, if you see at the left, you can see a graph that is taking the result for example, if you see, for example, the type of mineral fertilizer used, it's number B. So you can see that many farmers don't use any fertilizer. You can also characterize the type of fertilizer used. For example, if you see just for the organic, you see that mainly it's cattle manure. For example, another interesting result for E, you can see that most farmers don't apply the plant protection products based on agronomical advice, etc. So here we really see a characterization of the let's say the farm environment. And you see, for example, more specifically for the soils at the right, you can see that the results for many different nutrients. And you see that for some of them, they are at the optimum level. For example, if you say magnesium, the same 67% of the farms have good levels of magnesium. But if you see, for example, for the phosphorus, it's really like let's say the levels are very low, 85%, they are too low. So this really allows for a characterization of the farms.
One more
So
minute, Thomas. One more
yes,
minute.
yes, I'm almost finished. Yeah. So with these results, we did a scientific publication that is also accessible. You will see the link there. And what these tools will help us was to characterize the avocado production system in Uganda. And also we saw what are the challenges also that we find. Another result that we get, and we are also working on this, was to compare the soil, the results that we get from the soil analysis with on-field and wet chemistry, that is the references. So and the objective is really to compare if they are accurate, the results on the field are accurate compared to the wet chemistry, and if also we can derive good recommendations or not. So to conclude, this system, the supply chain management systems, are a suitable solution for data collection and mapping at the farmer and field level. If we integrate these soil scanners, we can also provide an accessible way of having soil analysis for the farmers, which are really lacking in the avocado and also on other production systems. But at the same time, we really need to confirm the accuracy of these soil scanners in the field, and that's why we are continuing to, because also they are very dependent on the calibration, so we still need to validate the performance of these soil scanners comparing to the wet chemistry, which are let's say on the lab soil analysis that are done on the lab. So yeah, that's in a nutshell what we did in this pilot, and thank you very much.
Thomas, we want to thank you for that very insightful presentation. Again, as I said at the last presentation, we need this sort of digitalized approach to getting the data that allow the farmers, the producers, to make key decisions to enhance their production and productivity. And if we want to really achieve improved food security and that reduction of the food import bill, these are the sort of technologies that we need to incorporate. But it's easy to sit here in this room or online and listen and not do anything with it. So I want to make an appeal to the persons here and online. Let's get the information out to the people who need to use the technology. I know CoLead is working with Cardi, and we do work with them as well as ICA. We want to call on ourselves, FAIRs, so that we can get the information out there. And I know this session is being recorded, so we want to encourage persons to take up the information. Thank you again, Dr. Lopez. I want to move on quickly to our next presenter who's here in the room, and that's Mr. Melvin Medina from our sister organization, FAO. And Melvin will be speaking on the plan. Well, let me not go there, and let me introduce him first. Now, Melvin is working with the FAO. He works for the sub-regional office of FAO in the Caribbean in Barbados as a plant production and protection officer. His background is in agronomy, and he was an engineering degree from the Agricultural University of Zamorano and a master's degree from the Polytechnic University of Cartagena in Spain. And also, he has a background in plant nutrition of intensive cropping systems. After managing private sector farms and owning farm-growing crops in El Salvador as well, he has been working providing technical support, increasing capacities of countries in areas of plant production and protection in South and Central America, the Caribbean here, East Africa, Central Asia, and Southeast Asia, promoting adaptation of technologies in the context of small-scale farmers. Now, let me just indicate to you all that Melvin is a dynamic speaker, and he joins us with a wealth of experience. Let me ask him to come to the platform. to the mic at this time and remind him he has 10 minutes. And I'm good at reminding persons. Melvin, the clock is running. Thank you.
All right, thank you. Thank you very much. And thank you, Alistair. All right, I wanted to present today some of the solutions that we are implementing in our projects and different countries. And basically, those are three different ones. The use of the digital sensors that we are installing inside the protected cultivation systems to improve the crop management. The other one is the soil scanner, something similar that was presented uh, by by the last presenter, integrating the soil scanner technology with other solutions. And the last one is a calculation tool for fertilizer applications for different crops. Okay, so first of all, this is about the sensors that you could see some of them in the booth that FAO has in the other room. Why we are using them? Well, to improve the monitoring of some critical parameters. We will see those parameters very soon. And those that affect directly the yield, and we can also see them in a real time also for extension services to advise farmers. Farmers and advisory services can be in a much better position to understand the changes on the crop. And this is important not only because we want to understand why this time the crop was performing much better than the previous crop cycle, or maybe the opposite. This time my crop was not performing well, and with this data we can understand uh, maybe the temperature was much better this year than last year, or the humidity, or many factors. So this can also help us to understand why. With this type of technology, we can also see the real-time data. So every minute we get one reading, and the ability to set up the thresholds, right? Because we are in the tropics, and we know that some of the main limiting factors are high temperature, high humidity. So we need to set up our thresholds, because we know that if we are cultivating, I don't know, any crop that is sensitive to low temperatures, then it cannot be the same thresholds as one crop that accept higher temperatures. This is a very practical example of what type of decisions we can make. One is this problem is a very common problem everywhere, and it's a calcium deficiency, right? This is in tomatoes, but this is the end of the problem, the calcium deficiency. But the calcium deficiency appears because um, the calcium is absorbed through the transpiration process, and the transpiration process will stop if we have high temperatures, or high humidity or low humidity. So in that case, we don't really have a calcium deficiency. Calcium deficiency appears because we have a very poor climate conditions inside the environment, inside the structure in this case, right? So in that case, even if you apply a lot of calcium, you will not solve the problem, because you don't have a calcium problem, you have a microclimate problem. Okay? So with these sensors, we can understand if the temperatures were not correct, combined with other parameters. Some of the limitations for the diffusion of this type of technology is that normally they have been expensive. Now we are trying to work with different options to bring down the costs and to make them available for small scale farmers, which are the majority in the Caribbean. the lack of technical support and expertise, how to use them, and also how to maintain those devices. The lack of awareness for extension services is the efficiency on the information flow, because this can be a very good tool for extension services to provide to provide higher quality services, having farmers and extension officers access to the data. So this is how the system works very quickly. The sensors are here installed. Those are probes. We have three different ones: water, parameters in water, parameters in soil, and parameters in the environment. So those are all sent to a microprocessor. The microprocessor sends the data to the cloud, and then from the cloud we have access in our phones or in our computers or tablets. Okay. We have also different options. There are two options, basically. Some of them are more open source technologies, and some of them are private commercial products, right? So the difference is basically prices, because these ones here, they have their own software, and you have to use their own software. And in the other case, it's more like a low cost. It can be also locally made. You know, these days, developing a website is not a big thing. There's a lot of young people that are IT. I am not one of those, but I know there are some very good ones that we can ask them, we can speak with them and ask them, please, can you develop this for me? And they will do it for a much lower cost. We have done it in countries like Vietnam. I had that experience, and it works very well, coming from 2,000 US dollars to a 200 US dollars. Yes. So these are all the different parameters. We have 17 different parameters that we can measure in a real time. Okay, this will give us data from the environment, from the water, and the soil. The three of them are now coming solar powered, so they are standalone systems. That's a very good one, because we don't need electricity anymore, and everyone has an international SIM card inside, so they will connect automatically to a network that is available in any country, right? So we don't have to worry about that anymore. Those are the new generations. The one that you're going to see outside are not. And this is how the software looks like. These are just numbers, and more numbers. And these are graphics that you can also retrieve these type of graphics for example, to see sunlight. You know, sunlight is a main source of energy for the plants to grow, and it is really important to keep it in a good level. So here in this graphic, we can see sunset, we can see sunrise, we can see if the day was too cloudy or it was a sunny day, right? For example, to see when to expand or when to retract a shade net inside the greenhouse, this can be very useful. Or when we need to clean the plastic films because they are getting dirty and the plants are not getting enough quality of light. Right, so some key messages take home very quickly because of the time. The sensors provide a lot of data, but we need together with the knowledge, with the knowledge of extension services, we need to provide better recommendations. To be effective, it has to be accompanied with optimized good agricultural practices, of course. And some farmers and entrepreneurs can also build this system low cost for us. The other one that very quickly is the soil scanner. The previous presenter shared some experiences of this technology in Africa. We are using them in Barbados and in Antigua. We selected those two countries because of the funds we have available were limited, and Barbados and Antigua are flat. that give us the opportunity to do a calibration process in a very relatively short period of time. So we did calibration in Barbados, we calibrated Antigua, and now extension services are using them. So this is what basically does is that you use it in any farm, you can have unlimited soil samples, results, and that can help you to advise farmer in a much better way. This is the result that you get from the soil scanner, all the different parameters. Of course, this is not to replace laboratories. Proper laboratories are important, but in countries where laboratories are not available for farmers, this can be one option. And the other one that I wanted to present is the, the online. Well, does it work?
It happened automatically, Steve, then?
Okay.
Oh, I think the Zoom link has crashed it. Well, conclude, please, Melvin. Conclude while we set it up.
Okay, sorry.
Yeah,
I'm going to conclude, yes. Right, so we are developing an a software application for calculation of fertilizers applications based on different things. Number one, based on the soil analysis result. Number two, based on the type of fertilizers that you select, because not in every country you will find the same type of fertilizers, and based on the crop requirement. So based on these three different factors, you can include them in a software application. Just click, enter all this information. We have 35 different crops coming. You select broccoli, melon, and then enter your fertilizer program, and then you select the fertilizers. What is your source of phosphorus? What is your source of potassium? What is the source of nitrogen, calcium, magnesium? And then automatically you will get the fertilizer program for any of those 35 different crops: fruit trees, vegetable crops, roots and tubers. Unfortunately, I cannot show you the beta, but if you are interested, please come to me and I will show you how it looks like after. And basically what you get is this, right? The application regime for that specific crop, for that specific soil. Um, it, you can do it, you can select the rate of application if you want to apply daily, every 2 weeks, 3 times per week, every month. It's up to you, right? Okay, so I'll stop there. Thank you very much.
Melvin for the win. So I'm glad he tried his best to stick to the time. Really invaluable insights. And I hope, again, as he said, that we take him up on the opportunity to get more information on this type of software and tools that they have available. I want to recognize some colleagues in the room, Mr. Dalton from ICA St. Vincent. Take this information back to St. Vincent. Marcus Maiku, as a great agronomist, take this back to Trinidad and Tobago and to the other colleagues from different parts of the region. Please don't hesitate to call on Cardi, to call on FAO for the information. We are here to share. I see my colleague, Dr. Eudoxie, in the back there at the university. We want to all work together to get this information out. And I'm talking about all these agencies because we're about collaboration. And I know we're talking about crops, but we want to flip the script a bit and go into the sea and look at the marine side of things. So we're going to go on to one of our colleagues from CRFM to do her presentation. After her presentation, then we will take some questions from the floor. So keep your questions. We know there are some burning issues to be raised, but just hold for a few more minutes. So I want to introduce my colleague, Lisa Carney. I hope I've gotten it right, or Khan. She's executive director and founder of Fragments of Hope, and she'll be telling us about the importance of tracking in situ temperature data for reef resilience monitoring and restoration planning. Now, Lisa is a marine biologist by training and founder of Fragments of Hope. It's a Belizean nonprofit that looks at coral reef restoration and community resilience. After moving to Belize in 1995 and witnessing the destruction caused by Hurricane Isis at the time, she pioneered coral replenishment techniques for endangered Acropora species, achieving restoration success in sites like Laughing Bird Cay National Park. Her work integrates environmental sensors and data collection to monitor reef health, guide restoration strategies, and support climate adaptation. With an MSc in Biodiversity Conservation and Sustainable Development, Lisa has earned international recognition for a science-based, community-driven approach to marine conservation. We want to invite Lisa to share with us, and let's, as I said, go to the marine side of things. Lisa, are you on?
I am on. Can you hear me?
Loud and clear. And Lisa, you have 10 minutes before I start showing you the yellow card.
Wonderful. Can you see my screen?
Yes, we can.
But thank you for the invitation. This is definitely not my audience. So I will be very thorough, hopefully, and quick. Just talking about how we use temperature sensors in the marine environment. Again, I have no idea who I'm speaking with. So corals are animals, but they live with algae inside them that photosynthesize, and then those algae are affected by sea surface temperatures. And when they get too hot, it's called coral bleaching. As you can see from the image, they turn white and they exit and they leave. And after a period of time, this will kill the coral. And some of you probably are aware that we're in the quote unquote fourth global bleaching event with dire sea temperatures right now. If you're wondering who me, I am from California originally, but I moved to Belize 30 years ago. So we've been doing this type of work. There's a little map of Belize. We're really in Central America, but with the Caribbean Sea here since 2006. And we've been using these underwater temperature loggers from, it's called Onset, or Hobo is the company name, since 2009. And I'm sharing the model here. They are about 150 US, I think, and they last around 5 years or so. And we retrieve them every year. So they did come with an underwater shuttle, but that didn't work. So we instead purchased multiple loggers so we can switch them out every year to collect the data, because the underwater logger, or the underwater shuttle, sorry, never really worked, which is another 200 odd US. So this slide is old from our, like I said, the bleaching event been going on since 2023, 2024. If you can see on the left-hand side, we've had maximum temperatures of up to 33.3 Celsius, which is quite high. And we've had major mortality events, just showing what it looks like. And here is what we do with the data from those underwater loggers. Excel gets kind of messy, so I had some colleagues working with our software that can put long-term data like this. So we were looking at one site in this case. In the previous case, this is multiple sites I'm comparing with the Celsius on the axis there. Just really hot. It's just really been hot, as you guys all know. It's hot right now. So this is what we're doing with some of the data. How does it help us? We need to decide which corals we want to select and propagate and move to which sites that might survive into the unfortunately predicted terrible future of continued long-term heat waves, which I guess you guys have been talking about in detail with climate change and agriculture. Just in the last year, we started using these, it's called SOFAR. The little image, the yellow sensor in the photo there has solar panels on it, and the big white buoy is just a surface support buoy. And this gives us real-time data, which is cool because, like I said, the other loggers, we switch them out every year or so and collect that data. But this you can get online, and it gives us the wave height, wave direction, speed, and sea surface temperature. And if I look miserable, it's because it's been over 32 Celsius for like weeks now, flat, calm, really beautiful weather for people on shore, but not great for the corals. So I hope I did under the 10 minutes, and that's all I have for Ono. So thanks for inviting me again.
Lisa, you did so well. You caught me off guard.
Yeah, well, I've been waiting online for a while, so I just wanted to share what I could share with Ono. So thank you again.
We appreciate it. highly. And for those who came in late, Lisa is from CRFM would have identified Lisa to us, and she has come from, I think it's Founders of Hope is the name of the organization, and she's looking at temperature data to guide
Sorry,
race.
it's fragments of hope, like a little fragment of coral, fragments of hope. Like we have a little bit of hope left, right? So fragments of hope, and it's carne, por favor. No me gusta carne. Thank you.
Oh, okay, we appreciate that. And at this time, let me just open up for a few minutes for some quick questions for the 4 presentations that came before. Any burning questions in the room? Or you all holding your questions till the end? Adrian, I don't know you as the expert in agromet. Any insights for us? Anything you want to share from what you heard so far? I have a mic. Any comments?
Regard to the first present.
I think it's for Vito. I'm not hearing you.
It's on. With
Great.
regard to the first presentation, I think it was done by St. Kitts on the app, the extension app. I had one question. It said there were different communities. So the St. Kitts community, in terms of the analysis of the disease or the pest, wouldn't it be better if the communities were linked together, especially for technical support and analysis to other communities? Because it seems to me that if you're limiting the analysis of pest and disease to one source, such as small community, it may be a new test, and therefore they may not have the technical skills to be able to identify that test in real time.
Well, the presenter has a mic in her hand already, and she's right next to you. Ms. Tucker?
Okay, so thank you for your question. So the way the app was created, the communities are separated, but we can share information via, or we can call each other by moderators, yeah, and share the information also, like the quarantine officers. If you find a disease on your farm, then a farmer can communicate with the quarantine officer once they're in the same community. And then the quarantine officer would then direct that to me, which is the moderator, and I can share that with other members or moderators from other communities, as in St. Vincent or in other areas where the app was launched.
Thank you.
Any more questions in the room or online? I think I see Dion's hand is up online. Ms. Clark Harris, oh no, that was an error, sorry. That's the cursor moving. Any comments online? Okay, there's a question online. Okay, there's no question. Okay, so if there are no more questions in the room or online, let me invite Ms. Bronte Tucker again, as well as Ms. Dion Clark Harris. You see, I was really thinking about Dion in advance, who will now be doing their presentation. And it's from Cardi again, and it's the use of AI-powered disease detection tools for bananas in St. Kitts and Nevis and Jamaica. So let me invite Bronte and Dion to do their presentation. And again, you have 10 minutes.
Okay, afternoon again. Bronte Tucker, Cardi rep for St. Kitts and Nevis, and I'll be presenting on the use of the Tumaini app, which is a banana disease detection tool here in St. Kitts and Nevis. Okay, so Tumaini was developed by SIAT, and it uses a comprehensive database of images to accurately diagnose diseases in banana plants. So when you download the app, it's gonna ask you to choose your location, right? Why it asks you to choose your location? Because then the app, when you detect a disease in banana, then the app uploads this information to a database, and then that database helps to track diseases, or the banana diseases. So with the Tumaini app, you could scan different parts of the banana plant to give a diagnosis. So you could scan the complete plant, the underground core. To scan the fruit, you have to do a cross-section of the fruit. You could scan the pseudostem, or the leaves, fruit bunch, or the bunch red sheet, right? So when you, in this instance, for example, when you scan the leaf of the plant, it's gonna give you the diagnosis. And if this, for example, with this scan of leaf, is gonna give you the accuracy, the percentage of accuracy of which it thinks that the disease was diagnosed. For this example, it's 65% accurate that the disease is the black cicotoca, right? So when you scan the disease and it identifies the disease, then it's gonna give you the symptoms, and it's gonna give you recommendations of how to control the disease. So here, back in April, the creators of the app came and we launched the pilot of the app, and then we did a live demonstration of how to use the app. So this is a banana field. It's the Department of Agriculture banana field demonstration plot is actually the Famosa banana. Yesterday, the director for ICA would have mentioned that they're doing work with TR4 Fusarium. So this is their banana, banana that they would have brought in as a trial to see if the Formosa banana can grow here in St. Kitts and Nevis, as it's supposedly resilient to the TR4 Fusarium. Right, so here we see members, technical staff of the Department of Agriculture, along with CARDI and farmers from St. Kitts, and both from St. Kitts and Nevis, doing live demonstration or live test of the app. Early in September, also, as a joint effort between the Department of Agriculture, ICA, and CARDI, we did a digital workshop where the app was also introduced to farmers, and we did testing on how to maneuver the app or how to use the app and test for different banana diseases. So the app can detect approximately 7 different diseases in banana: black cicotoca, moko disease, fusarium wilt, and others. So in conclusion, the Tumaini app can be used as disease surveillance tool, geographic mapping of affected banana plants facilitate the tracking and distribution of disease over time. Recommendations offered by the app helps farmers to implement timely intervention. And the Tumaini app aims to equip farmers with tools to safeguard their banana plant against disease, improve yield, and enhance food security. And that's it from my side. Dorian, Dion?
Yes, good afternoon. Would you allow me to just share my screen now, please? Yes, good afternoon, everyone. I'm just going to follow on from what Bronte just shared with you to give you our experiences in Jamaica using the same app. My slides are not advancing. Okay. So Bronte would have given you an overview, but just to say that this initiative is part of a bigger program, Digital Tools for Transforming Agri-Food Systems, and we're doing it not just in Jamaica and St. Kitts and Nevis, but in St. Vincent and the Grenadines and Guyana, with funding support from APC Colombia. The initiative is geared towards development of Caribbean agriculture through deployment of digital technologies that have been researched. And in Jamaica, an assessment was done of Jamaica's readiness for digital transformation. And the 3 barriers listed below, inadequate infrastructure, economic constraints, and low digital literacy, have been highlighted as key impediments to transformation right now. So having identified those needs for Jamaica, the key objectives of the initiative using the Tumaini app was to build capacity, that is to train farmers, researchers, and policymakers, boost our resilience through using the tools towards climate smart decisions, and to pilot innovation such as the Tumaini app among local users. And in the case of Tumaini, we identified 26 local users. So the key activities in Jamaica to date, one has been a 2-day training workshop held with the focus on the banana disease surveillance tool, Tumaini, and the key local implementing partners that we worked with are the Ministry of Agriculture, Fisheries and Mining, the Banana Board, which is a board that has responsibility for banana industry in Jamaica. And we thought them a key player that would be using the Tumaini app, and they have been helping us to lead the implementation of this pilot, along with a private sector company, the Jamaica Producers Group Limited, which is a huge producer of bananas in Jamaica. So the main topics of this 2-day workshop were looking at Tumaini, the AI-based solution, but also the opportunity was taken to present on the use of unmanned aerial vehicles and drones, and for the use of these for monitoring crops. And they also looked at the regulations and some drone software. Participants also got introduced to flight mapping and surveillance using the drones. Now, cell phones and the app were provided to the participants to test them in the field, test the digital tool Tumaini in the field when they left the workshop. All right, okay, so these are the workshop participants. This is how they were distributed. Along with the implementing partners I mentioned earlier, we also had the Rural Development Authority, which is the extension officers. We had the Research and Development Division of the Ministry of Agriculture, Plan Quarantine. We also had some ICT persons who are developers themselves, as well as an agro-investment body and CARDI as participants in this workshop. And some of the seeds from using the Tumaini app aspect of the workshop are shown here, where, as Bronte would have shown in her presentation, you have scanning of the leaves with the phones, which would generate some outcome. And in all cases within the workshop, the plants were confirmed, well, identified to be healthy plants. And you see the output output screens here from the app, having shown the pictures that were scanned using the cell phones. And these are the participants that are using the phones which were given to them during the workshop. and to take back to their respective places. So what were the stakeholder feedback? I mean,
Two more
we
minutes,
have been
Dion. 2
hearing.
more minutes.
Yeah, sure, I'll be finished shortly. So within that post-workshop period of over 3 months, we have had varying uses of the funds that were given to the participants. And that was how much they use it was based on their substantive roles. And of course, the extension officers used it most frequently, up to once per week, saying it was easy to use, no technical issues, and so on. The key benefits were deemed to be for pest ID, GPS mapping, and farmer communication, because the farmers got to see firsthand what was happening with their plants. The suggested improvements was that they would needed to add more crops to this particular app, put some more features for the geospatial aspects, and to incorporate more educational resources and be able to share and scan images that they have. But they were very satisfied and would recommend the app. So the way forward, stakeholders found it to be suitable and effective. We would want to, as I said, expand the crops covered under the app, target the deployment to those extension officers and field staff that really deal with bananas in this case, so that you have more impact. You want to improve some aspects of the app features, monitor and evaluate through follow-up assessments, and to integrate this into the national pest disease surveillance and reporting frameworks. Just wanted to also acknowledge again the supporters of this initiative, both the International Center for Tropical Agriculture, CIAT, as well as the Presidential Agency, APC, Presidential Agency for International Cooperation of Colombia, the Ministry of Agriculture, Fisheries and Mining in Jamaica, the Banana Board, the Jamaica Producers Group. Thank you for listening, and that's the Jamaican experience with the Tumaini.
Thank you, Dion. I know Bronte has to make a quick comment. Bronte?
Okay, sorry, I forgot to mention that the Tumaini app, if you want to do a live test, we have it at the Cardi booth in the exhibition in the ballroom. So we have the phones there that Dion would have mentioned, and we have some samples of banana leaf. So you could actually take a picture with the Tumaini app, scan the leaves, and detect the disease. Thank you.
Thank you, Bronte. I have to go and check that out, because I find we have some really, really interesting tools and solutions being offered here. And I want to appeal to the agencies, please, let's work together. Go to Cardi, bombard Mr. Shah and his team, get access to the tools, share it with the farmers, share it with the extensionists. I want to make an appeal to Cardi and the other agencies here. Let's use, we have CAIPNet in the region, a regional extension network. Let's encourage them to have monthly sessions with extensionists where you can share the tools with them so that they can incorporate it and share it with the farmers. I myself, I plant planting, and this would be a useful tool for me. I'll expose some of my business here. I always have to harass Mr. Shah. He's laughing to come and help me and give me advice. If he had told me about this tool, I could have been using it and getting better production and dealing with my issues. So I want to applaud Cardi for sharing this technology, and let's get on board. I want to move on quickly to the next presenter, and I know that they are a bit ahead of us in terms of time zone, and that's Ms. Tanya de Groothus. She's from the FAO, and she'll be doing identification and traceability systems. Tanya, I know that you've been on for some time, so I don't want to keep you on. Oh, you're in the room. Oh my goodness. Tanya shall left you for last then. So let me introduce Tanya. She's a livestock specialist at the sub-regional office of the FAO. She's an experienced livestock specialist with a solid background in sustainable animal production and environmental conservation. Prior to joining the FAO, she served for 8 years at the Ministry of Agriculture in Suriname, where she contributed to national livestock development initiatives. Tanya's professional interest and passion She's deeply committed to promoting sustainable livestock production practices. She advocates for systems that ensure the production of high quality meat while safeguarding animal welfare, human health, and the environment. Let me welcome her. Let her know she has 10 minutes. And let me say Faraka.
Hi. This one? I wanted, yeah, thank you. Good afternoon, everybody. Thank you for the introduction. So I wanted to give a brief presentation about the animal identification and traceability system that we've been using in the CARICOM region since 2022. Yes. So we started in 2022 with, well, 2020. So yes, we started in 2020 with phase 1 of the project. In that phase, we had 5 countries: Guyana, St. Vincent and the Grenadines, St. Lucia, Antigua and Barbuda, and Barbados. These countries now, and you see a picture there of the, I think it's the Antigua module. So our system, the NITE system, the National Animal Identification and Traceability System, was developed by FAO in the EU for the EU countries to be able to report to the EU. This system is transferable to other countries, so it's not only for the EU, because it's easily customized to the needs of the countries. So in the first phase of the project, these 5 countries received the their national animal identification and traceability system. Key point here is that this system is completely owned by the country. So it is not, their data is their data. When we have finished customizing it to the country, it is given to the country so that they are the only ones that have access to it. We did a review of their legal framework to be able to identify gaps in regulations and policies that would hinder them using or rolling out a national animal identification and traceability system. We gave recommendations, and I am very happy to report that Barbados and Guyana are very much ahead of everybody with moving forward with implementation of the system. So Barbados has implemented some of the, or is in the process of implementing some of the legal changes or recommendations that were put forward, as well as Guyana as well. What we did during that phase is we also worked with the countries to develop a strategy for them to roll out their animal identification and traceability system. And based on that strategy, the system was customized to their workflows and their rules and regulations in the country. And then we also did we did training for extension officers, training for the ministry, and all of that training is now available on YouTube for free in training videos. And then we also developed a manual for the animal identification and traceability system that is also available online. So any country that is now doing the same project can, well, access the training material, as well as the countries that already have it. If they have new staff on, if they take on new staff, they have access to the training videos and the manual. So phase 2 started in 2024, where we started with the Bahamas, Trinidad and Tobago, Grenada, Dominica, St. Kitts and Nevis, and Jamaica. These countries are now receiving the animal identification and traceability system. It is being customized momentarily. It's being customized to their systems. So for phase 2, we had a slightly different objective. The first objective, of course, is to give the countries this system that they can use. But we also wanted to include CARICOM because so many countries already have it. It provides us with a way of standardized reporting of animal diseases, of food safety data, so that this can be provided or can be reported to CARICOM, which would enhance interregional trade of animals and animal products. And of course, we wanted to use the AIT system for evidence-based decision-making within the region for genetic resources, livestock production, as well as animal health management. This tool, standardized reporting of animal diseases and diagnostics, would support or strengthen regional surveillance of animal diseases. So this is just a snapshot of where we are in phase 2. We are in the process of reviewing the legal framework and working on an agreement for regional data sharing of livestock production, livestock data. So this agreement will be amongst countries that do want to participate for now, and then as we move forward, we will see if more countries are willing to participate as well. The software, as I said, the software is being customized. We are now in the customization phase 1, where we are gathering the information from the countries on how they want their system to look, what they want, how their workflows are, and so forth. And then we will move on to piloting. Because the system is already developed, we don't have to really pilot in the sense of testing it out. What we are doing with the pilot is implementing it in 1 or 2 regions of the country, so that the relevant stakeholders in the country can get used to the system, learn how it works, and that we can also strengthen workflows in the country. So a bit about the system itself. The NIGHT system focuses around individual animals and follows the animal through its life cycle. So we register individual animals, their owners, as well as their holdings. So the place where they are kept. So this data is captured in GIS data within the system as well, so that we can show locations of animals on the map. And then through that registration, we can trace the animal's movement throughout its life cycle, and also trace the animals if they are exported, or include animals that are imported into the country. We can also trace the animal's health throughout its life cycle through vaccination, as well as laboratory diagnostics. So every time a disease is treated, or the animal is treated or vaccinated or treated for any disease, this is tracked in the system. And then when the animal is slaughtered, it is also we are also able to track all the products from that one animal. So the consumer will be able to get access to that animal's history through scanning the labels that are printed from the system. So these are the animals that can be registered through the system. So different species can be registered. You can register individual animals, livestock, pets, so cows, sheep. We can individually register them. We can also register groups of animals. So for example, if you have a group of in a specific life cycle. So if you have heifers or calves, you can register them as a group, but you can also register flocks or herds. So that makes it possible for us to register even aquaculture, schools of fish, as well as in beekeeping, we can register the groups. This is it. Yeah. So this is the core, these are the core functions of the system. As I said, this is just a snapshot of what the system can do. We have a slaughterhouse interface. We can trace the animals, and in terms of food safety, we can trace the animal's history through its products. Now, the animal production module that tracks the genetics, the meat, the production of the animal, the AI, reproduction, milk production, and so forth, is captured in a separate system that is linked to the NATES, which is the livestock farm management system, which can be given to farmers to be able to reg well, more efficiently do their bookkeeping and housekeeping on farm. So this is also linked to the NICE system, and in phase 2 of the project, this is also given to the farmer. So once the animal is registered, the farmer can go on to the livestock farm management system that he has, and only he has access to include all his productivity data, and that will support his farm management. Yes, that's it. Thank you so much.
Thank you very much, Tanya. Very, very practical. In fact, we were doing a disaster management plan for Barbados, and we were talking about this particular system that you all have there for you. So again, I appeal to the audience, those online as well, join us in promoting this technology, etc. And thanks for sticking to the time, Tanya. I want to move on to our next in-person presenter, and he has been waiting a long time, so I want to bring him up to the mic now, and that's Mr. Adrian Trotman. He's an agro-meteorologist and Chief of Applied Meteorology and Hydrology at the Caribbean Institute for Meteorology and Hydrology. Adrian is the Chief of Applied Meteorology and Climatology at, okay, that's the technology, digital solutions. He is the Chief of Applied Meteorology and Climatology at CIMH, as I indicated. And he works with this particular group in terms of applied meteorology and climatology. And they form the core of the Regional Climate Center for the Caribbean, as designated by the World Meteorological Organization. And Adrian leads that group, and he has responsibility for climate-related issues, including data management and dissemination and the provision of weather and climate information and services to multiple socioeconomic sectors. In his technical capacity, he focuses most on the agriculture and food sector with his specialized training and many years of experience in agro-meteorology in the Caribbean. He has and continues to manage several regional programs and projects related to weather and climate applications and services across the region. The narrative is much longer, but that's a shortened version. Adrian, welcome, and 10 minutes.
Yes, this is slated to last 9 minutes and 59 seconds, Alistair, to be exact.
But I will time you there. Let me see.
Yes, so what I'm going to do here is to look at how we provide climate, weather and climate early warning information. So it might be a bit different to what you would see in an agriculture setting like this. But what I propose to do is to look at the information starting with the data, down to the products and services at the end. So let me get this going quickly. So some of this stuff you might have seen from previous presenters. We have data collecting systems, whether it be automatic weather stations, water level sensors to gauge stream and river levels. But we also have remotely sensed data from satellite, from radar, and even now these days, you had the first session looking at drones. So these AWSs provide us with information related to rainfall, temperature. We've seen a lot of this presented earlier. But also, when it comes to agriculture, there's some stations that allow you to have things like soil moisture information, even estimation of potential evapotranspiration, and so on. But what we're also interested in, apart from meteorological data, is non-meteorological data as well. For example, vegetation indices, land cover, and so on. And we sometimes get this not only from data collected in our countries, but there's some international sources. And I mentioned an example here of Copernicus. We also support data rescue. In fact, there's data rescue going on that we are supporting in Jamaica and Dominica. This is climatic data, many years of data that's handwritten, and it's not necessarily easily digitized, but we have, with the support of optical character recognition and using an open source system, we have scripted our own so that we get like 90% accuracy of our reading in handwritten data. So this is looking, we can't go back. All right, okay. Right, so right now we are talking about acquiring the data, but what we also talk about when it comes to tools and information and using the technology is managing the data. And we've scripted a number of data management systems in the region. We at CIMH are finalizing a climate data management system, but I want also to talk about data that's not necessarily climatic. For example, we will soon be releasing, as you see here, the Caribbean Climate Impacts database. So that's managing data that, for example, what were the impacts from floods, hurricanes, drought, and so on. And we have a multi-hazard platform called the WETRA, where it's utilizing a number of bits of data, whether it be vulnerability data, exposure data, hazard data, climatic data, to at the end to provide us with impacts-based forecasts. And this is basically, I'm not going to skip through this one quickly. This is looking at the interface, the front end of the data management system we are creating. I'm not going to go into that. But then, most important, if you have data, what are you doing to use that data? Capturing data, storing data is useless until you find a way to provide meaningful information for potential users of that data. And I already mentioned to you the impacts-based forecasting and the WETRA. The WETRA platform, as I said, has a suite of data. You could have farms, it could have infrastructure, it could talk about rivers, have rivers all embedded. What if the data suggests, for example, in this map of Barbados, suppose we were to say, well, we had farms inside here, and we had a system that was probably going to dump some water across parts of Barbados. We can see the farms that might be impacted and so on. So that's an example of where it can be used. But what we also do, and we'll see this in a bit, using the data, as I said, we're about early warning information. So we start from the weather scale, that's hours to a few days ahead, up to 6 months in advance, using these tools, these two tools here, the climate predictability tool, and our in-house built harmonizing experimental system integrated with the climate predictability tool to provide early warning information for the Caribbean. We also utilize international databases, and we have established a fire weather monitoring tool at CIMH, which could be very, very useful for agriculture because it identifies areas in countries that are potentially prone to fire weather, and that we are seeing it potentially playing out at the particular time. Now they are. Yeah, so at the end of the day, as I said, when you talk about utilizing the data, so at the end of the day, we're able to provide in these examples what we call climate information or seasonal climate information, from drought to rainfall, temperatures, and so on, forecasted 3 to 6 months in advance. I know some of you talk about meteorologists and climatologists. You can't even forecast for the next day. So how can you forecast for 3 to 6 months in advance? All you got to do is come to this session and plug for the next session that we'll be leading on Thursday afternoon at 3:30 in this very room. You can see where we go from here with respect to climate monitoring, seasonal forecasting. So we talk about monitoring the climate. We are talking about long-range seasonal forecast, 3 to 6 months in advance, as I said to you, and you can see the types of things we forecast over that 3 to 6 month period. We even have, apart from things like wet days, potential for flooding, drought alerting, extreme temperatures, heat waves, all these things we forecast 3 to 6 months in advance. And I saw a couple of the marine presentations. We even do talk about Caribbean coral reef watch as well, that we run in collaboration with the National Oceanic and Atmospheric Administration. Again, we are talking about early warning, forecasting, providing information well in advance that can support contingency planning in the agriculture sector, including fisheries, as you can see when it comes to coral reef watch. Try again. Okay. More recently, our forecast, though, we are looking at seasonal information, sub-seasonal information, forecast 1, 2, and up to 4 weeks in advance. So we do this every week. These are a couple of examples here. This is not yet operational, but it will soon be operational in our platform, Carrigen. So it might be interesting to know, and these are examples here from Monday, 22nd of September, for the next 6 days. So that's 7 days, that's a week. What's the probability of rainfall exceeding 30 millimeters in any of the countries in the region? Or number of dry days in a week? What are the forecasted number of dry days? Of course, from 0 all the way up to 7 the entire week. So that's the sort of information we provide. And the last thing I want to mention quickly is weather forecasting using artificial intelligence and machine learning. And there's been a lot of work done across the globe in utilizing AI and ML. I have some examples here. We have, for example, the UK Met Office have the world's first cloud-based supercomputer dedicated to weather and climate science. And the thing about this is how fast it can do its calculations. So it can perform 60 quadrillion, I don't know how many zeros that is, to be honest with you, calculations in just 1 second. So you can imagine that when you talk about weather forecasting and you say, okay, I don't know how accurate these things can be. Part of the problem is that all the data, all the calculations, it takes much more computing power, and we are now acquiring this computing power. There's also the example from the European Center for Medium Range Weather Forecasting, right? So we recognize that it has their work up until this time has improved our forecast by up to 20%. There's one concern though, because if you know anything about artificial intelligence, it means you're training the data on history, right? The thing is, if you follow the Texas floods recently, many would tell you that some of these AI models didn't forecast that Texas flood very well. And one of the reasons is that if it's an extreme event like that, it means there are not many examples in history to be able to train your AI system, right? But we're working on that, right? One of the means of working on things like that, if you want to just read up on this here, Destination Earth. It's funded by the European Union. What it's doing is is establishing, developing a digital replica of our planet, right? They call it digital twinning, right? So it will provide, by 2030, mind you, and it will provide us with a greater understanding of our changing climate. Right? Yeah, it's just one more slide after this, right? So I just want you also to know that CIMH is getting involved in this AI technology for forecasting. Just last week, we had an expert from the European Center for Medium Range Weather Forecasting embedded at CIMH so we can start working on this for the Caribbean. So I'm going to be promising you, right, that in months to come, we will be improving our weather forecasting using AI and ML in the Caribbean with support from the Caribbean Institute for Meteorology and Hydrology. 9 minutes, 59 seconds, I thank you.
Actually, over 11 minutes, Adrian, by my clock. So your AI projection forecasting was a little bit off today. But yeah, maybe we can take the questions after everybody is finished, so we'll wrap up. I think that we've been hearing some good information. Again, I'll say that. And Adrian, will be, I hope there's continued collaboration between CIMH and CARDI so that we can convert that meteorological data into more agromet to give farmers some guidance how to produce. Because having the information, as you said, without being able to apply it is something that we really need to explore going forward. I know time is running away from us, so I'm asking you all to bear with us in terms of the questions online and in the audience. We just have 2 more presentations and we're going to be quick. I want to call on Nicholas de la Masa. And Nicholas joins us from Agrojusto. He's the Chief Executive Officer, Chief Executive Commercial at Agrojusto. And he was a participant in our recent Digital Agriculture Week at ICA headquarters. A really wonderful week of sharing what ag techs are doing and providing solutions as well for the whole hemisphere. And Nicholas is a specialist in digital business development and a growth expert for impact startups. He's self-taught and passionate about innovation. He has mentored teams and international projects across Latin America, helping organizations implement digital solutions that connect local producers with differentiated markets. His approach combines business, strategy, technology, and social impact. Now, I'm a marketer by training, so this excites me. So I want to hear more about Agrojusto and ask Nicholas to join us. Nicholas, can you hear us?
Hello, thank you so much for the introduction. Good afternoon.
Great. Nicholas, 10 minutes. Floor is yours.
Okay, first of all, I want to clarify that my native language is Spanish, so I would gonna go read today, and I will try to present in English so everyone can better understand our work. So, like you say, my name is Nicolás de la Masa. I'm Chief Commercial Executive of Agrojusto. And in America Latina, there are more than 50 million family farmers that they represent 80% of all farmers. But they face 3 big problems. First, they have low access to markets and depend on middlemen who almost never pay fair prices. Second, they have low income because of this unfair system. And third, young people do not want to stay in farming, so there is no generational change. The woman in the picture is Fernanda Boneso. She is the CEO of Agrojusto and the daughter of farmers from Mendoza, Argentina. She lives these problems with her own family and decided to take action. With 3 friends, she created a platform to support small farmers, to give visibility to their products and to connect them with buyers through simple digital tools that solves their main challenge. How does Agrojusto work? We focus not only on the supply side, but also on the demand side with our platforms. Our solutions include online stores made for farmers, blockchain traceability tools so buyers know the origin and the people behind each product with 1 click, and store connected with traceability profiles so every product shows its own story and good practices. Training programs on sales, marketing, certifications, gender, and others. A world-scale marketplace where buyers can connect directly with farmers, a community space for users to connect and share, and a dynamic marketplace portal join different stores together to build stronger visibility. Let me share to you one story. This is Sylvie, a beekeeper from southern Mendoza. She loved bees, but her labels could not explain all her good practices, so she couldn't not reach better markets. With all tools, she creates traceability profiles, learns sales skills, and digitalized her business. Now, she could sell to Michelin-starred restaurants. We started in Argentina, but we soon saw three big gaps across the region. Few new ideas in rural business strategies, few teams focus on rural business, and very high cost of technology. That's why we scale our business model through wide-level solutions, working with strategic alliances, and our broader platforms helps address these challenges by adapting to each partner's needs and delivering the best technology to farmers across Latin America. Our first success story was in Mexico with the program Orígenes Digital in collaboration with New UUP. We support 42 producers' organizations to strengthen their skills and digitalize their products. In these programs, we create custom digital tools and impact measurement system because what we cannot measure cannot be improved, sales portals and digital training platforms, and a program for young rural entrepreneurs. We also work in Chile on Rapa Nui Island with the cooperative Umanga Capé. They need to show the unique origin of their products and share the good practices of their farmers so they could reach better markets. Our tools help them create traceability profiles, digitalize their products, and connect directly with buyers. And in Guatemala, we are support the coffee organizations Capé Ewan Naha with the Care Foundations, helping them do the same, show the origin, highlight good practices, and reach new markets. On these slides, you can see some of our partnerships, Nu, ProMujer, Startup Chile, Rookstock, and others. And all of this is possible thanks to our specialized team. At the top, you will see the four founders, and in the bottom, the experts in each area. We are also supported by advisors and investors like Carlos Beco, Sergio Asís, and Rubén Adman, and by organizations like Kirchner Impact Foundations, Grupo Sancor Seguros, and the Swiss Cooperation for Development. Our work is aligned with the United Nations Sustainable Development Goals. We have moved more than $1 million in transactions with over 300,000 food products sold. Our community includes more than 6,300 farmers and businesses. And we also launched the first academy for young rural entrepreneurs in Mexico. Today, we have more than 26,000 members in our Just community, and we received many awards. The Bayer Foundation Legacy Award, recognitions from the IDB Lab, 2 awards from the United Nations, and also from Startup Chile. Thank you so much for your attention. And in this QR code, you can find my contact details if you would like to continue the conversation.
Nicholas, we want to thank you for sticking to the time, and this information is quite useful. I hope that we can try to incorporate some more of this kind of information in our production, planning, and actual marketing. And I know in the region, that's something we've often explored, but somehow we can't seem to get it right. So we'll probably be engaging you going forward, Nicholas, for more information on these sort of buyer-seller type interactions and linkages. Thank you again, Nicholas.
Thank you so much.
And again, congratulations on your recent activity at the Digital Agriculture Week. I want to close up this session by having my colleague, my esteemed colleague from CADI, Dr. Anika Minot, do a presentation for us. Anika, are you on? Anika, just trying to make sure you're on.
Good afternoon.
Oh, okay, we're hearing you now, Anika. And I want to introduce Anika. She's going to be doing a presentation on IoT sensor technology for real-time detection at the South American palm weevil larvae in coconuts. Anika is based in Cadiz, Jamaica, and she has been in the institute, I think, an estimated 10 years, and she is a specialist in pathology and in entomology, as far as I remember. And she is one of the bright young scientists at Cadiz, and she brings a wealth of knowledge to this forum, and we're really excited to hear from her. Anika, the platform is yours.
Good. Thank you. So I'm just going to be presenting on a pilot study that we would have used the IO3 sensor, which uses Internet of technology, and also some weather stations in detecting for the South American palm weevil real time. And this was facilitated by an EU funded project, which was looking at coastal resiliency. Okay, so coconut, and well, as islanders, we know that coconut is very important on many dimensions: social, aesthetics for your tourism, um, and economic as well. Unfortunately, we have an issue. We have a lot of old trees. We have a lot of high susceptibility to pests and diseases, and these become their challenges for coconut production. And the target in this case is the South American palm weevil, which is present in a number of countries. But unfortunately, we can only detect this problem when it's late, because most of the damaging stage, which is the larva, goes undetected in the tree. And currently, our technology is limited to use a pheromone which detects for the adult stage. So our basis is that if we can detect early, then we can save the trees and we can, apply timely mitigation strategies, and it also allows us to monitor health. So these were our objectives, and that's the pest, the target pest. We have the male and the female there. Uh, what I present on is mainly observation, cause are basically work example of learning. So we have a lot of lessons learned. We had to work with the software to adjust some of the equipment, and thankful that it's a pilot, so we would have facilitated for that. So not only did we want to detect for the pests, we want to also gather data, because pests is not a pest animals, diseases, they're not in isolation, they occur in an environment. So on a micro level, we thought it best to have weather stations installed. And the weather stations of Bulgaria, ProIntegra, Agromet station, and some of the functions would be measuring soil temperature and soil moisture, and you can do it at different depths. We also have the capability to measure leaf wetness and also solar irradiance. And it in itself, it allows us to be able to predict for disease. So, if depending on how long the leaf is wet, then you can predict for some of your leaf diseases and so forth. So we wanted a full picture. And in addition to that, now we have the ability to see if the larva, to detect the larva in the tree. And this was once hidden. So our weather stations, um, so just some screenshots of the interface. So the first one, is just some sites in Trinidad where we're looking at the temperature, and this is today. And the other one looking at rain, and here the one in the middle is looking at the wind speed. And for the site in Guarguare, we can look to see a summary of that, and the one to the far right, looking at rain to see, it's also predicting how much rain. So this sends a measurement every 10 minutes in real time. So this is one of the glitches we had. So the sensors, some of them would have been developed to go with 2G technology, and in the course of us doing the project, that was phased out across the countries, or the countries, by the way, Trinidad and Tobago, St. John and St. Vincent and the Grenadines. So we would have had to work with the suppliers to adjust for that, so we are able to collect the data. Back now to the sensor observation. So the tree sensor, it is so that is placed in the tree, trunk of the tree, at specific parts of the tree, and it detects the vibrations while the larva is feeding. It can detect as little as a size of 1 centimeter, and so they're installing the tree according to the supplier statements, and each tree now, when it's installed, they're geotagged, and then you have the ability to interact with the interface, and then basically identify the trees that are suspected or clean. That is, they don't think that allure is present. And you have different variations in terms of the suspicion. Some can be highly suspected, some can be just suspicious. So in the field, we also would have used the trap. So we did have some back and forth with the supplier on this as well. So we would have to adjust the technology because some of the gateways weren't working. As I would have mentioned before, it's pilot. So we were able to work through some of those. And but in the meantime, this is the trap data, the pheromone trap, and we disaggregated based on sex. And what you see in here is that we had a lower amount of females than male over this particular period. And this one is looking at the number of dead trees and the number of weevils, and we're seeing like a general decline in the area. And this is the traps in terms of with the traps. So because we had to work on some of these issues, what we noticed, and this is for one because that one was consistently okay during the time, we noticed that some trees, they died, and they were the sensor would have indicated that they were suspicious. So in a total of 149 trees, we had a decline mortality rate over the time. And what we did was we looked at the observation of tree deaths over the time for the trees that, and we noticed that the sensors would have given a status of being suspicious or infested, and then they end up dying. And what we realized now, the average number of days for death was about 180 days. And we know that the life cycle of the South American palm weevil is between 80 and 180 days. So just some of the sensors here with that information. And so I can only report observationally, but from on that basis, we see that where IPM is important. And we saw where the trees took about 180 days to die. And what we now have set up is basically a set of living labs. where these sensors are, because we now have the weather stations and we now have the trees with the sensors on them. So this gives us the ability to collect data from both the weather station and the sensors, and we can explore trends, see if we can find any variable that is influencing population, for example. And we can also test for chemical options as well in terms of managing for this pest. And in terms of our strategic recommendations, it would be great if we can continue to enhance training and education opportunities for farmers and make use of the sensors where present for targeted treatment in the intervention, among others. And I'm going to take this as our call to action to continue IPM interventions and to continue partnerships in, in order for us to continue the pilot evaluations on treatment options for management of South American palm weevil. And basically, the possibilities are S, because as I said before, we now have a living lab where we can go in and test options, not only for this pest, but possibly other tunneling insects, other insects that their life cycle is inside the palm, and even the weather station, because of that ability where we're collecting leaf wetness and other parameters. We can also look into forecast models for diseases. And the data in terms of the weather that is concentrated in these areas too will be helpful for the southern farmers. So the possibilities are endless. Thank you so much. I hope I didn't go over my time.
Anika, let me thank you for that presentation. You were on time just by over a few seconds, but we really want to applaud the effort. And I think the information has been useful. Again, I make an open call. We need to find a way to package the information to make it available to the users, the beneficiaries of the information. As Adrian said in the presentation before, we can't just have information. We must be able to channel it into something that will allow for proper decision making and make it useful. I want to therefore open up the floor at this point for questions. Any questions from the audience? I know we've had a long day, but sometimes we have to keep plowing on in order to get growth. So I want to thank you all for sticking around. But any questions from the floor? I see Ms. Worrell has a question in the back. Liana?
Thank you. Great presentations from everybody. I'm just wondering about the level of accuracy of the Tumaini app. I was a little curious about that. And then what exactly is the technology behind the app? Is it AI? How exactly does it work by just scanning those photos? And then for Mr. Trotman, the databases that you showed in your presentations, are those available to the public as well? The ones that are able to predict the weather patterns? Just wondering if that's something that we could just log on to one of your websites and have access to that information. And if so, is it packageable that the layman like me would understand it?
Okay, thank you for your question. So for the one that referred to the Tumaini app, so yes, it's a mobile app, right, that uses picture-based, how should I put it? So it uses photo to recognize the disease. So it has like a database, photo database that recognizes the disease based on the picture. So you have to try and get the picture as close as possible so that it could detect the disease, right? Hope that answers it. So again, with each picture, the app would tell you the level of accuracy automatically. So then at times it will tell you 85%, at times it will tell you 60%. If it's below 50, then it just won't recognize it.
Okay, if that's the answer to the first question, we can ask Adrian to respond.
Yeah, sure. I hope that means that I will see you on Thursday afternoon at 3:30 in this room. That's when you learn more than I'm up to respond with now. Yes? So one of the ways we have disseminated, and we work with the region, we train the national Met services to do the same thing for their countries, but we work at a regional scale. Yeah? Every month, we produce what's called the Caribbean Agroclimatic Bulletin. And in there are advisories with which we work with CARDI so that they talk your language in agriculture. So CARDI supports the advisories that's in that bulletin, and we do that every month, right? So because we produce new climate products every month for the next 3 to 6 months. Yeah? So that's part of the answer. The other part of the answer, which is more detailed, comes on Thursday. Yeah.
So Adrian, when I said more work with Cardi, I was wrong then. That's already taking place.
CARDI is our partner. We have a consortium of multiple sectors, and CARDI is our agriculture partner.
You see, again, as a farmer, and my colleague, Mr. Shah, doesn't share that information with me for me to make decisions, you know, so I'm a bit uncomfortable right now, you know.
The consortium since 2015, yeah.
I was working Cardi then, no? So. Mm-hmm.
But in a larger scale, we tend to target more like extension officers. We train extension officers to be able to deliver that to the farmers they serve. Okay? Because dealing directly with farmers on this might not be the easiest way to go. We have an approach called PICSA that some people are familiar with, Participatory Integrated Climate Services for Agriculture, which supports farmers. We have to train them first. We train the extension officers who train them to understand and work with the information. So it's a kind of multiple tiered approach here.
Well, Melvin was with me in a session earlier on extension. He'll tell you we've been talking about how can we synchronize the approaches to extension to do the very same to get the information out there, because a lot of times we can't expect the CIMH, the CARDI, the ECAs, the FAOs to get the information directly to the farmers. The extensionists have to do that. And we need a proper platform that they could access the information from you all and then disseminate information. So I think we need to do a little more talking, and there's the CAIPNet, the providers network, that has to play a greater role engaging you all to support you all in getting the information out there. Any more questions? Thanks for that, Liana. Any more questions from the audience? I think, well, I should be grateful. Let me, oh, I see Michael Dalton from ECA. Yes, sure, Michael, sure.
Yeah, good afternoon, everyone. Michael Dalton. I'm from ECA, from the delegation in St. Vincent and the Grenadines. Just a quick comment, because I know that we're running very late. Alistair, this was an excellent session, if I may say so, as well as the earlier activity as well. That was excellent. Really, really good presentation. I just have a little concern though, because some of these applications and some of these bits of work, I didn't even know they were taking place across the region. And obviously applicable to St. Vincent as they are to many of the other countries across the region. And I think this is a deficit here because I'm seeing so many overlaps, right? And I'm wondering, and in some instances, I wouldn't be surprised if some of the consultants are not working on several of these initiatives that are overlapping themselves. But that's another conversation. But I think we need some sort of a clearinghouse. That's the first thing. If we are undertaking a project in this particular area, surely at the beginning, at the conceptualization stage, somebody must be doing an environmental scan to determine what work is happening out there already, so that we don't go about reinventing the wheel. That's the first thing. The second thing, it has to do with the dissemination across to the stakeholder. And this is where the extension services come in. And I think there is a disconnect that is happening. I'm seeing it for myself in the country. I don't think the extension services in many instances are aware of many of the products that are now available. They are aware of some. I know some of the organizations have been making a consistent effort to work with some of the extension services in some of the countries, but I am not seeing these things in widespread use across extension, as I've been speaking to extension officers, not only in St. Vincent, but across some of the other countries. This is something that we have to pay particular attention to. Otherwise, I think we will come back here next year with even more apps, and they will not be used. And I myself, too, have had that experience, that, and maybe somewhat guilty of it too, because we had the AgriX app from ICA that we had launched and that we recently relaunched again. And one of the commitments I had to do in the relaunch, because I had a cross section of both farmers and extension officers, is to get a commitment for us to work together as we try to promote the app across the landscape in St. Vincent. So just those 2 points. The first point of really trying to avoid the overlap, because we are wasting money, I think, especially when some of these initiatives seem to be large. I listened this morning, right? And the second point, that we need to see how we properly engage with the extension services to really propagate these apps properly to the stakeholders of the country. Thanks.
Michael, let me thank you for that. I think, Mr. Shah, last comment, if we can be brief, because it's 6 o'clock. Nothing online. Go ahead.
All right, so Michael, I agree with you. We need to have a clearinghouse. What I could see is that at least for these pilots we ran this year, I recall we did have a meeting with all of the agencies back in February. You may not have been online, but I know ICA may have been represented by, I don't remember who, but I think it's Dr. Denise, I believe, may have been there, and a couple of persons, and all the agencies, CIMH was there, and FAO and so on, to introduce the apps that we were about pilots, right? So what, and well, yeah, you're right, in the sense that we said 1 year ago, we need as the agencies to really have one united effort. So I agree, the core is that we should meet after here and really action that collaboration. So, but I think we did start to do some work. I have seen some progress from last year to now, though, in terms of digital applications. I mean, I think what we presented today were results of work that started last year. Last year, we would have presented on the same IoT app, but now we have data to show how it has performed, and that's what we try to do with the other 2 pilots that we're doing as well. So yes, we have, that is the focus we need, as you rightly say. But so we need to have that joint collaboration, and then the issue of, exposing the extension and so on to the other countries. So these apps, there will be some scale up towards the end of the year, in terms of when they are launched officially. Right now we are the pilot phase. All right, but I agree with you. Yeah, understood. But generally, and it's the same thing for the other commodities. When we met on the root crops today, it's the same scenario. We cannot be working, separately. At the end of the day, for all of the commodities, we have to come together and everybody decide what we're doing, what each one doing.
Folks, again, let me thank everyone for sticking around, those online, those who are present in the room. A special appreciation for your participation. For the presenters, really awesome and exceptional information shared. I thank all the 9 presenters who are on this afternoon and the ones from this morning. I think as Michael and Fayaz close off by sharing, a lot is happening, a lot of invaluable insights we got here, good tools that can really allow us to achieve our 25 plus 5. It's to get the information out, it's to continue working with the presenters and the persons who are doing the work, who are in the trenches. We appreciate what you're doing. We appreciate the agencies who are here, the partners who joined in making this session a reality. We want to see more action, and we are confident if we continue in this vein, we will see more progress. So colleagues, again, have a wonderful afternoon. Have a wonderful rest of the CWA week, and I look forward to interacting with you